Next up, we have the valve removal tool. So I need to replace this part because this one's broken, and apparently these things get so tight. My brother-in-law broke 3 of these trying to get the valve out of his boat. So you unscrew the top part. This goes on one side of the plastic. This goes on the other side of the rubber, and then this cinches down to make an airtight seal. And you crank it with this tool here, but you need to make them so tight, or especially after they've been on there a while, that the plastic ones break. So we're going to make a metal replacement, but a variation on this. All right, so I've got this chunk of brass here, and the first thing I'm going to do is I'm going to I'm going to face it, then I'm going to reduce the diameter of this rear section so that I can hold it in a 5C collet, because I want to put it in my collet block. I need to slit it 6 slits, each at 45 degrees from each other. So call this 0, 45, 90. And if I go all the way through, that will generate all of my slits. So we need to be able to put this guy in something that will allow me to do 45-degree angles. And I've got an approach for that, and we'll see how it works out. Here's 200 thousandths off the outside. All right, let's see what that does. That's a much faster feed rate. Okie dokie. Now we're going to put it in the collet block and flip it around. Second thought, we're going to hold off on the collet block until we do this side. We're going to start and get the outside to dimension. It almost is exactly right on dimension. That's why I used this piece of scrap, because it's almost perfect. Shooting for 1.220 and it's like 1.228. Okay, perfect. So we're going to bore out the inside, and we want the inside to be 1.062 inches. So that's removing almost all of it. And so we're going a depth here of 0.655. So we're going to start by boring out a fairly big chunk. I don't know what this is, but it's pretty big. A couple hundred thousandths, I think, 200 thousandths. Getting the last 62 thousandths. We only go in 350 for this one. I'm sort of duplicating this inside section here that also has a relief. Could have made that a little thicker, but I think that'll be fine. Next step, we're going to drill out the center of this, which is the back of this socket, which is this portion here. And the back of this socket is going to be broached for a 3/8 inch socket. So I need to pre-drill. I've got that broach on order, so we'll wait until we get it, and then we'll drill out the center. Next up, we're going to drill the pilot hole for the square 3/8 inch broach that will be going through here for the socket. This is 1/64 over 3/8. And we went all the way through because there's no reason not to in this case. Next up, slitting saw. We used our slitting saw to touch off on the top of the part. And then we're going to go down half the diameter, half the thickness of the slitting saw, and half the diameter of the part, which is a total of 0.671. And we should be good right there. And that, just by looks, also is center, which is good. And next we need to touch off in the X direction. All right, so that's X0. And we need to go in a total depth of 0.350. So we're going to come back here. We're going to go in 350. And I think we're just going to try and do this all at once. So we're going to lock our x-axis here. And we're going to run this in back gear. Oops. I tend to run these slitting saws fairly low RPM. And you just go kind of slow. So we're at about 140 RPM. This is brass, so it shouldn't be too hard. Okay, that was good. That was our first cut. Now we're going to jump to 90 and then we'll come back to 45. So, going to need some deburring on this, of course. I'm going to take this guy, pop him out, flip him 90. I've got my 0 set based on this stop for depth. And should be good to go. Oops, did it again. My regular forward, not back gear forward. I was freaking out there a bit because I noticed that it wouldn't be symmetrical with just 3 cuts, but it's actually going to be 4 cuts because I got to do each 45 here as well, and then we'll be done. So now, how do I get the 45s? That's the next trick. So we've got a low profile V block in the bottom at 45. Fortunately, this square holder has flat edges on it, which is very handy, and I might want to make those somewhat larger in the future because that is a very handy feature because it just catches below the top of the vise. So I'm getting a good bite on this whole flat area up here that you see, and we're going to do our 2 45s. Here's one and there's the other. Same thing. And that was one. And here is the last one. Next up, I'm going to part this guy off the base that I'm using to hold it in place, and we're going to broach it. All right, so we're all set up here. And it should go pretty easily because it's brass. It's probably going to require a little extension piece to push it all the way through, but I think we'll be good. And I'm using the air motor part of the jack on my hydraulic press to help make this easier. And I'm not using lube because this is brass. Wow, I didn't think the jack had this much range. And that's it. So I'm going to have to add a little extension here to push the last bit. And I need to put a box underneath it to catch it so the square brooch doesn't get damaged, because even this Chinese made one was almost $200. All right, so we put a pin here, and we're going to try and push the last bit through. Hand holding the camera makes it a little challenging. And we're there. A nice, mostly square hole. Okay, so here's the old one. And when I saw it when I was editing this video, I thought this top gap was more, and it was not symmetrical, but that's just because it's broken off here. So there's the valve piece that it attaches to. All right, so there it is, and here's the 3/8 inch drive. Could cross drill a hole for the ball detent. I might do that at some point in the future, but gets a really good bite on it, and I don't think this is going to break anytime soon. Very versatile, so I'll send this over to my brother-in-law and he can try and fix his inflatable boat. Everyone's wondering if I'm still wearing the Rock Rooster slip-on boots. That's a big thumbs up. They're wonderfully comfortable. Right there, it protected my toe. Just this last project, it dropped a piece of 1/2 inch plate steel on my toe, and they were protected by the steel-toed boots. But they're incredibly comfortable, so you wouldn't think they're like your regular work boots. They slip on very easily. I don't even need to reach down and grab the pull-up stirrups here. I can just slip my foot right in, and they're not too loose. It only took about 2 times wearing them for them to break in as much to be perfectly comfortable and easily slide on. So I'm giving them a big recommendation. If you're interested, I'll put a link below in the description, and check out their website. They constantly have sales, and their prices, even without a sale, are extremely reasonable for such high quality boots. Finally, I think we have some time to take this on a run through of surfacing, facing off this material with and without the wiper, and see if the wiper helps. So first we'll try it without, and then we'll try it with. All right, so we're set up and ready to go. First pass, we're going to do 25 thousandths depth of cut, and that's without a wiper. And then we'll do the other half, 25 thousandths, with a wiper. And you can see them side by side. I'm very interested to see how this works out. All right, let's swap out an insert. This looks like a good candidate. It's facing me, right? So whereas the other insert had 8 cutting edges, this one has 2 because these are dual-sided inserts. So I ordered these inserts from Germany. The manufacturer is this company. I've never heard of them before. JD Tools. And I ordered it based on the part number from the ISCAR site. So I'm hoping this is going to be correct. And we're going to pass in the same direction. Hopefully, this thing's not sticking down a lot more than the other cutters, because that could be a real problem. It looks about right. There's got to be some way to set that up. Okay. I think we're ready to go. Gotta say, it's got me spooked a little bit. Wow. Okay, that's not right. I'm gonna say that's not working, or a couple things possibly. Holy cow, that's just nasty. One, it's not the right insert even though it had the right part number. Two, you can only take super light cuts with it. That's a possibility too, I suppose. And three, I didn't set it up right. Maybe you have to dial it in or something, which I'm not sure how. So you'll notice there, it's canting in the holder, which it should not do. Hopefully I did not just damage my very expensive ISCAR cutter head. But I'm going to guess these are not the right inserts. Holy cow. This is the back side of that insert, and apparently it was rubbing in several spots and blew out the carbide. Totally destroyed the insert. These are quite expensive. The front side apparently never touched at all. I thought, when I first looked at it, I go, well, I don't know why it's making all that noise, because it's not doing anything at all, but there you go. That's a total mess. So one thing I noticed is the sides of these inserts are perpendicular, more or less. Yeah, they are perpendicular to the faces. These guys are sloped each side to the middle, and they cup underneath this holder. So didn't catch that first time. And so I'm guessing these are not the right inserts, even though they have the right part number. I put the original insert back in, and I'm just cleaning up this mild steel stock here because I use it on my hydraulic press. So I've increased the RPM, I've decreased the depth of cut to 5 thousandths for a finish pass, and you can get an okay finish with this without the wiper insert. And I guess I'll have to keep looking. Maybe I'll have to buy it directly from Iscar at like 28 bucks an insert. So there you go. There was an unsuccessful test, but I did learn something. Thanks for watching. Hope you find it useful. Hope to see you next time.